Welcome to the Explainer. Today we're going to talk about the Python programming language, and we're using a course in Python as our guide. And what's so cool about Python is that it looks like this super simple tool, but it's actually hiding some absolutely incredible power. So to see what I'm talking about, let's start with a really famous puzzle from way back. There was this brilliant mathematician, Leonhard Euler, and he made a bold claim, a conjecture, which is kind of like a really educated guess that stumped everyone for centuries.
He basically said that it was impossible to take three numbers, raise each one to the fourth power, and have them add up to another number raised to the fourth power. And you know what? It seemed right. For more than 200 years, nobody could prove him wrong. That is, until 1988. A counterexample, just one case that proves the whole idea wrong was finally found. And here's the kicker. Python can handle these gigantic numbers with no problem at all. And it can check in an instant that Euler's long-standing idea was, well, wrong.
And that right there is the whole idea we're digging into today. When you first look at Python, you might think, oh, it's just a simple calculator. But right under the surface, there's this incredible, powerful world waiting for you. So how in the world does a language like Python pull off these amazing calculations? Well, like with anything, it all comes down to the basics, the fundamental building blocks that every program is made of. Okay, first things first, we need a way to hold on to our information. In programming, we use something called a variable. Now, don't think of it like a box. It's more like a label or a sticky note that you attach to a piece of data, whether that's a number, some text, you name it. And these labels, these variables, they can point to all kinds of different data. The ones you'll see all the time are integers, which are just your regular whole numbers, floats, which are any numbers with a decimal point, and strings, which is just a fancy word for text. All right, now this is super important, so lean in. A single equal sign is for assignment. That's you telling Python, hey, from now on, this label points to this value. But a double equal sign, that's for comparison. That's you asking Python, hey, are these two things the same? And Python will just answer true or false. Okay, so we've got our basic ingredients, right? We have variables and different types of data. But to cook up anything interesting, we need a way to organize them, kind of like putting everything together for a recipe. In Python, the number one way to do that is with a list. And it's pretty much what it sounds like. It's a container that holds a bunch of items in order. The best part? You can totally mix and match different kinds of data in the same list. And this is a perfect example of why people love Python. It's just so simple and intuitive. If you want the first item, you just ask for item 0, because programmers start counting at 0. Want the last item? Easy, just ask for -1. And if you want a whole chunk out of the middle, you can just grab a slice. It just makes sense. So now we can store our data and we can organize it. This is where we get to the really fun stuff. This is where we unlock Python's true superpowers and give our program some seriously cool new abilities. We do this by importing libraries, and a library is just a collection of code that someone else already wrote. Think of it like a specialized toolkit. Instead of building a tool from scratch every time, you just import a toolkit for, say, advanced math, or for making graphics, or pretty much anything you can think of. And this is where it gets really, really interesting. See, different libraries can look at the exact same problem in completely different ways. The question stops being just about getting the right answer and starts being about what kind of answer you're looking for. Check this out. If we use the standard math or NumPy libraries to do a calculation, they give us a really, really precise decimal number. It's a fantastic approximation, but at the end of the day, it's just a number. But then look at what the SymPy library does. It gives us the exact mathematical formula. It's not just calculating a result, it actually understands the math itself. And that's the key takeaway here. When you use a symbolic library like SymPy, Python stops being just a calculator that's crunching numbers. It's actually doing algebra. It understands the symbols, the relationships, the whole shebang. And that is an incredibly powerful idea. Okay, so we've got data, we can organize it in lists, and we have these powerful libraries to process it in really smart ways. So let's put it all together and actually bring some data to life. We're going to start really simple here with just two lists of numbers. The first one has our x values, and the second one has the y values that go with them, calculated from a sine wave. Right now, it's just a table of raw, kind of boring numbers. But then we import another library, this one called matplotlib. And with just a single simple command,
we can instantly turn that boring table of numbers into a beautiful, clear visual graph. Just like that, we've turned raw data into actual understanding.
And there you have it. In just a few minutes, we've gone from a simple little calculator all the way to doing advanced algebra and creating cool data visualizations. You can see how these simple little pieces start to combine into something seriously powerful. You know, the author of our source material, Ruzbeh Hazrat, really hits the nail on the head here. The absolute best way to learn this stuff isn't just to read about it. It's to get your hands dirty, to experiment, to break things, and then to build your own stuff from the pieces. So the most important thing to take away from all this is that these tools, from a simple variable all the way to advanced symbolic math, they're right there at your fingertips. The real power isn't just in the programming language, it's in what you decide to create with it. So the only question left is, what are you going to build first?